Yeah. Out in the yard where the grass grows wild, CiottiFPV's goggles locked, grinning like a child. Teddy spaghetti's, fur flies, and jet wash dreams. Yeah. Chasing small whoops like a dog possessed fiend. Eyes on a neon blur, hard in the chase. Big fuzz and prop spin, all tangled in place. Yeah. Four-legged rebel with a rotor stir tail in the circus of the sky. They never fail. CiottiFPV, Teddy spaghetti, dynamic duo kings, barking at the breeze, throttling at top speed. They zooming through hoops, flipping in style. That schnauzer's got throttle and a toothy smile. Yeah. Shotties on sticks, Teddy's on paws. Side by side legends breaking all the laws. Through the kitchen over couch scale terrain. Backyard mayhem in their flight domain. No ground too sacred, no loop too tight. Fuzz fuel fury ignites the night. When pilot and pup lock eyes on the prize, every whoop they conquer is a fresh cut surprise. Yeah. Yo, Shotty behind the sticks, Teddy's leading the pack. Prop guard missiles unleashed, never looking back. No leash, no map, just freestyle Mike. They on the dog drone streets every day and night. Said whoops, hitting low, gotta nail the dive. Teddy push throttle up, feel the beast come alive.
Hey friends, my name's Aaron Ciotti. We're gonna try this again. I'm now connected to YouTube's backup server, and I've got green, so we should be all right. And I have 0 dropped frames. Something's going on with YouTube's main live streaming server. So tonight, we are going to test 4 different 1002 motors. We've got a Happy model, a sub 250, a Flywoo, and a GEPRC. All 1002s. The GEPRC is the most interesting. It is 25,000 kV. The Happy model is 20,000 kV. The sub 250 is 21,000 kV. And the Flywoo is... Wow, I can't even read it with a 5x loop. 1980 kV. Jeez. Flywoo, come on, man. I've got them all bolted down to this Mobula 7 V4 frame. I'm going to put this X12 into it, and then we're going to use my Toolkit P200 adjustable bench power supply to feed a steady 4 volts through a capacitor and a spike absorber into the BT 2.0 into this X12, just like we've done in all of the previous testing. Patrons, if you hit Tech Talk in the top right corner of Patreon, it'll pull up a whole bunch of really good stuff. One of the really good things in there is a spreadsheet called CiottiFPV Tiny Whoop Data with loads of good info. Lots of weights, motor heights, tons of motor testing. And one of the things that I've done is test 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20... like at least 25 different motors, what their actual kV is, because the different manufacturers have different methods of measuring kV. So when you buy a Betaflight 30,000 kV motor, it's not going to be the same kV, actual kV, as a newbie drone 30,000 or a Happy model 30,000. And so I've done a whole bunch of kV testing using the same test setup so that you can actually look at how these different motors compare to one another, because the kV that's stamped on the bell doesn't really mean much of anything. I've also done prop on testing with a ton of these motors. I'm not going to do that. I don't think I'm going to do that tonight. Maybe I will. But the fucking around with YouTube just ate up the last like hour. So We're definitely going to test the KV because I'm super curious if this GEPRC 25,000 is going to give me an actual like higher KV than all of the other 1002 and 1102s that we've got. Yeah, you know, I might as well throw a prop on it. I just have to try to remember how I tested that. Why does it say volt? I'm looking at the spreadsheet now. 1210 prop, and then it says voltage at 100%. What does that mean? Does that mean I tested them at 3.8 volts? It's been a while since I've done this testing, so RPM at 100%. How did I do this? What did I do here? RPM at 100%. Voltage at 100%. I think I tested it. It looks like I tested it at 3.8 volts. I might have to go back and watch one of those old live streams where I did the motor testing, but luckily I put dates in here, 8/18/2024, and then it looks like I did some more testing on 11/17/2024. So yeah, this is going to be pretty cool, and then we're going to see if this thing will fly with 4 different motors, 4 different KVs. We've always talked about this, how the PID loop runs at 4,000 or 3,200 or 8,000 cycles a second, and it should easily be able to take 4 different motors or 4 different propellers and even them out so that they fly normally, but we're going to test it if we have time. I just... Get out of here, fly. Why do the flies always come around as soon as I start live streaming? I need to take this one motor off of here that is just bare wires and solder on a JST 1.25 or whatever it is, 1.0 or 1.25, I forget which it is. And so, yeah, you're going to get to see that. I'll give you some soldering tips. Actually, you know what? This is an awful lot to try to knock out in an hour. So I'm going to get caught up on chat right now. And then do me a favor, hold your questions until Friday, and I'll get all caught up on Friday. But let's try to get as much of this done as possible. So hold your questions in the chat. But I want to get caught up right now. Nyafu says, could we get a stream on 1002 versus 1003 versus 1102 versus 1103 on 2-inch? I see people use all 4, and no one can agree on which. Also, what happened to 0603, 0703, and 0803? 603 is only a 2-to-1 ratio, and so the motors get too hot. 703 is sort of a similar scenario. 7.3, almost 2-to-1. Motor gets a little bit too hot. 803, also 703s are a little bit too heavy. 803s, there aren't any good ones with 1.5 millimeter motor shafts in a proper KV. Same sort of issue with 703. There are no 703s with a 1.5 millimeter motor shaft. So yeah, 703 and 803 are basically just motor shaft and KV limited. There's not a good combination of those things for a motor that would make any sense for us. And then 603s overheat. 603 sort of also has the same problem where it's 1 millimeter motor shaft only. The motor is so heavy that you end up bending the motor shaft. So 702 is the way to go for 65 millimeter rigs, and then 802 or... Are there multiples in here now? Sons of bitches. And then in terms of 2-inch, 1002, 1003, 1102, 1103, I am going to do a stream comparing the Happy Model 1103s to the Flywoo Robo 1003s. You wouldn't really want to go smaller than 1003, though, I don't think. So, yeah, we're going to compare those two. The Happy Model 1103 11,000s, though, are a no-brainer. They're so good. You pair them up with the Gemfan 2023S tri-blade propellers, and it's just an awesome setup. I'm hoping that these 1003 14,800s, though, will allow me to use the 2015 bi-blades, so we'll see. McShaky says, gives new meaning to crotch rocket in that video. I see what you did there. Striker says, hello. My friend finished sub 250 high speed. We're calling it Pocket Rocket. He's going to test it soon. It's running 4100 kV FPV cycle 16 on 6S 550. It's 249 point something. That's ridiculous. Those motors are probably going to cook, to be honest. I don't think those motors are going to last the first full throttle hit, but it'll be interesting to see. We're going to try HQ 315 by 2.8 HQ, or the ESC is going to explode. But I think it's going to be the motors that are going to explode. Which do you think will be faster, higher pitch, smaller prop, or larger prop? Smaller prop, higher pitch should always be faster than larger prop, lower pitch. Because it's going to blow a higher mile an hour of thrust. Goated04 says, I want some better outdoor performance on newer Meteor 75 Pro. What frames, props, and canopy would you recommend? If it's 1S, your best bet is going to be to go to a Air 75 V2 or Mobula 7 V4 frame, and then Gemfan 1610 biblades with the Weebleed Treetoppers 802 33,000 kV motors. That's like sort of the only setup that's really all that interesting on a 75mm 1S build. Striker says, also, do you have any thoughts on the HQ props for the Grinderino yet? Nope, I haven't had a chance to run them. All right, cool. Hold your questions until next live stream. Let's get to work here so that we can actually hopefully get something done. I need to go here with this. We're going to get Omni-Fixoed. I'm going to turn on the soldering iron. We're going to put this guy in here. I'm going to clamp on... I hate to do it, but I'm going to clamp on the... Oh, I can't. Shit, hold on. Can I clamp it like that? Yes, I can. All right, so we'll run double Omni-Fixos here. Give it a little lean. And, okay, I need a motor plug. I think I might have one up here. Let's see. All right, so soldering iron is set to 700 degrees Fahrenheit. I find that to be a perfect middle ground where I don't have to bounce the temperature of the soldering iron up and down and up and down and up and down. It is not too hot to do 30 gauge wires as long as you're quick, which I am. And then it's not too low to be able to do big wires. So again, I mainly do that to save me from having to bounce the temperature up and down. So basically it's me being lazy, if I'm completely honest here. But you do you, my friends. You can be lazy. I ain't gonna tell nobody. I'm taking a quick look here at... I have a wire here. I just want to make sure it's going to be long enough. So it sits right there. And yeah, it looks like this. It looks like this guy will be just barely long enough here. So help me God, though, if I do all this and then it's not long enough, I'm going to punch somebody. So do I have another one here? Do I have... I do. Here is a red one that is... Oh, nope, the red one's not even any longer. Cool, I'm using this black one. It's fine. All right. If this isn't long enough, I'm going to punch someone. Fair warning. Okay, soldering iron is up to temperature. I'm going to put some flux paste on these solder joints. On the last live stream where I opened this motor up, I realized that this they used liquid electric tape on these on the solder joints here, which is super annoying. And I peeled that off with my fingernail. And now we are going to remove all three of these. That should be super quick. 1, 2, 3. Something's going on the computer. I think there's like a file playing. Hold on. Turn the volume up. Yeah, something's playing on the computer. What's happening here? What am I hearing? Hold on. example of that. Oh, that's the banged up live stream that's playing. On this document. The hell's going on here? That's a weird warning. The stream's current bitrate is lower than the recommended bitrate. What the hell? 6,800. What? I didn't change that. Why is the bitrate so low? 6,800. Bitrate. Output. Encoder settings. 2,500. Oh, wow. Yeah, 2,500. Why is that so low? Oh, I can't change it because I'm... Well, maybe I can. Will that let me? Maybe that works. That'd be cool if that works. Okay. Hopefully things just got better. So... Good connection. Okay, that's good. Where in the hell was that audio just coming from, though? That was super weird. Is it coming out of Discord? It might be coming out of Discord. I think it was coming out of Discord. Alright, I think we're good. Let's keep going here. So... Nerd got... Oh, no! 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 What the hell? No! I hate it. I hate that that just happened. I'm gonna glue it. I hate so much that that happened. I'm gonna super glue it like a straight up donkey. Oh my god, I've had these for a long time though. These have had a good long life. These here nerd goggles. Right. So, let's just crank this on here. And take this off. All right. Wow, I can't see what I just went to put these on to see what I was doing, but I couldn't because I'm trying to fix them. Okay. Big old B to super glue. Oh, that's way too much. And it's not gonna be. Oh, for Christ's sakes! It's not gonna be strong enough anyway. But I mean, it's worth a shot. As long as I don't glue it to the side of my head, I'm happy. Buy big packages of little things of super glue, my friends. If you don't, they will dry out. Even this one will dry out. I will not use enough of this super glue by the time it dries out. I've bought so many different kinds of super glue with so many different like nozzle setups, including a really fancy, really nice looking Loctite one, and it just doesn't work. They die. They harden, and that's the end of that. So I do have these. I tried to get these. I don't know. They're like, they have little LEDs in the corners here, and I thought maybe these would have it. These have a little bit of magnification, but they don't have enough. They're not as good as these. But these will certainly help me out. Without some kind of magnification, I can't work on these fucking tiny whoops. I am every bit of 44 years old now, and my vision is absolutely shitting its pants, almost as bad as YouTube was tonight. Okay, here we go. So we got our plug. I always like to do these middle wire to the middle, right wire to the right, left wire to the left. And so let's get that rocking and rolling here. And then I'll also just take a quick look at the AIO and figure out where the plug part goes. Okay, so I'm going to do it like this. This is just, to be honest, this is just me being completely insane, for the record. But if you're going to be insane, Really go for it. Really go all the way. All right, so I put a little bit of flux on there when I removed those wires, so there's still some flux residue. Should be just enough. I'm going to put my left arm down on the table so that I can hold these wires with my left hand really stable. I'm going to do the left wire first so that I'm not crossing over myself. And you know what I am going to do is I'm going to put a little bit of shrink wrap on this guy. One of the things that Happy Model does is they put a little piece of shrink wrap that so the part on the motor, the PCB on the motor with 1, 2, 3 motor pads is like this. If you put a piece of shrink wrap over that, it'll prevent the wires from bending at a really hard angle right on top of that connector, and that'll help the wires last a ton longer. You could also technically do it with like a big blob of E6000, but to be honest, just use shrink wrap. It just kind of works. And so let me get a little piece of shrinky dink here. Doesn't look like I have any in there. And so you just want it to be ever so slightly bigger than that little part of the PCB. And so that kind of means that this should be just about right. Nope, not quite big enough. And is this one? This is the one. Here we go. You don't need much, just a tiny little bit. And chop it off, and you're going to put it over the wires themselves. It's actually probably a better idea to do clear. I just did black, but if you do clear, then if you've got wires breaking, you'll be able to see them. But the point of this is that the wires don't break. And so we're going to put it over here and just slide it all the way down to the plug so it's not getting in the way of these wires. And then get your wires straightened back out. Again, I'm trying to go middle to middle, right to right, left to left. And so let me just check that. Yeah, I think I'm good. I think that's it. Okay. So this part facing upwards. Get your hand into a comfortable position where you can hold it really steady. It really does matter. Put your magnification back on your face so that you can see what the hell you're doing. Left arm, left forearm flat down on the table, and then your right wrist you want down on the table. You want as much bone support as you can possibly get here. Hold the wire in the perfect spot, and then use the tip of the soldering iron to bring the heat in. Don't use the tip of the soldering iron to try to hold the wire, because you have to remove the tip of the soldering iron. And so if you're not holding the wire in the perfect spot, with your left hand, when you remove the tip of the soldering iron, the wire is going to move. So what's going on right now is the heat is not transferring. So what I'm going to do is I'm just going to pick up a little tiny blob of solder on the tip of the soldering iron. This is called hold on. This is called tinning the tip of the soldering iron. There was one. Here comes the middle one. And now what just happened is the middle and right pads just bridged. And so what I just did is I heated up that solder bridge and then pulled off of the pad quickly, and that'll do a really good job clearing the solder bridge. I've got one wire that's perfectly on here. Here's a little trick. I want to redo this second one just to make sure that it's not bridged. And so you can bring your tweezers in at a 90 degree angle and just pinch both of these wires. This will hold them in place. Hit that second pad with the soldering iron again. That makes absolutely sure that there's no bridge. And now I'm going to use these sharp-tipped tweezers to do the third wire here real quick. I took a bunch of solder off of that pad when I was clearing that bridge, and now there's not enough solder, so I need to pick up a little bit of solder on the tip of the iron, and we're just going to use that to add it. All right, I got that almost perfect, but I'm going to do that little trick again. I'm going to hold all three. I'm going to pick a little bit more solder up on the tip of the iron, and I'm just going to hit this pad one more time. That's looking much better. Do not clean the tip of the soldering iron before you put it back in the station. Leave it with solder on it, so that you can, which helps the tip not oxidize. The solder itself doesn't oxidize, the tip oxidizes it. So clean the tip when you take it out of the soldering iron stand. Don't clean it when you put it back in there. And those three look really good. You want them to be shiny and smooth. And so now we pull this shrink wrap back down, push it up over the PCB. Basically just push it as far onto the stator as you possibly can. And then we're just going to hit it with a lighter to shrink it down super quick. And we're done. Okay. Just hit it a tiny little bit more. There we go. That's it. So now we got a nice little piece of shrink wrap that's going to make these wires hopefully not bend super hard at the joint. See that? That little piece of shrink wrap is super helpful. It did slide down off the PCB a little bit, but it should be on the PCB just enough. Let me just take a look with the 5X loop. Yeah, it's just barely on the PCB enough. Shit. All right, well, hold up. I want it to be a little bit farther on the PCB. So if you take your sharp-tipped needle nose pliers, you can put it into the shrink wrap, and then you can just open it back up and stretch it back out. It's probably smarter just to cut it off, but just put it in there and just stretch it back out. Shrink wrap you can do this and then shrink it back again. Just a little bit of pressure there. And now that might actually allow me... No, I gotta go back on there. Yeah, I gotta stretch the whole thing out. There we go. There we go. All right, cool. So now the whole thing is stretched out. So we're gonna hit it lightly with heat this time, and then we're gonna push it up on there farther, and then we're gonna hit it with heat again. I'm gonna pay a little bit more attention this time. All right. Oh, you know what? It was actually fine. It's I see what's happening. It's hanging up on where the windings come out. Sometimes you can't get it all the way up there, because of the way the windings kind of block it, so to speak. But this is looking pretty good. Let me just real quick stretch it a little bit more. I'm watching the show Euphoric on HBO Max. It's pretty good. Just kind of bouncing around looking for stuff to play in the background while I'm twerking. All right. That's the ticket. Get up on there. There we go. Jesus. Hold on. I'm not stretching it out enough. I'm being like super careful with it. I need to just... There we go. There we go. That's enough that time. That's more than enough. Okay. Shrink wrap. There we go. Yep. All right, so... I'm just going to leave my finger there and just burn myself real quick. I want you to keep the heat moving. Doesn't hurt too bad. And now I'm just going to scooch it up a little bit again. yeah, where the way that the windings sit on this, it really makes it hard to get this shrink wrap up here on the PCB. It keeps kind of scooching it off. I did not need to do all this. I should have just left it alone. It was as good as it was going to get the first time. But, so let's get it back to that point real quick here. All right. That's exactly where it was. All right. That's good to go. So, let me bolt this back to the frame. What is happening over here? Get off of there. There it is. Let me bolt this back to the frame real quick here, and we'll get that adjustable power supply fired up. Well, actually, no. I gotta get the I'm gonna get the AIO dropped into this frame next, and then we can get the power supply fired back up. And what we're gonna do is we're gonna go into Betaflight, and use the motors tab to bring these motors up to 50%. That's where I think that's where I was testing the KV numbers at, and then there was a calculation. KV is actually tested, I believe, at 100% throttle, but the problem that we have with these 8-bit ESCs and these tiny little really high KV motors is that there's a cap on how high of an RPM an 8-bit ESC can push a motor. And so if we spin these motors at 100%, they will cap that out, and they won't turn. They hit, like, I forget what the number is. I think it's like 85,000 RPM, and they won't spin any faster than that. And so all the motors spin at the same speed when you do 100%. Luckily, in the real world, we put propellers on these things when we fly them, and that drags the RPM down. I don't think I've ever seen much more than like 65,000 RPM. And so there we go. Now we have a proper motor plug in this motor. It's kind of insane that I had to do that. 1002 motors, as far as I'm concerned, should all have motor plugs already on them. But hey, what do I know? I just work here. Here we go. We're going to ram this 1S LED plug through here. There we go. That was actually much easier than last time. And now we're going to drop this X12 down onto this Happy Model V4 frame. All right. There we go. And I don't really need to secure the camera, but I'm going to, because we are going to fly this thing. I have a 1S 450 mAh battery on the charger, and we are going to test 4 different motors, 4 different KVs, being able to still fly. What is this? Do I have some screws over here? No, I don't. Do I have some here? I do. Here we go. 1, 2, 3, 4. Okay, so this is an X12 AIO, and then I've got a Runcam Nano 3 camera on here. 4 different motors that I called out a little bit earlier in the live stream. I'll call them out again in a second. Wow, man, I can't see shit. Hold on. All right, these glasses help quite a bit. I think these glasses are basically just like reading glasses. I don't think they really have much of a correction to them. I think they just have a little bit of zoom to them. This screw is going in here a little bit crooked. And so what I'm going to do is I'm going to lift up on the frame. And you see how that popped out? That's what happens when the screw goes between the plastic post and the rubber grommet. You always got to be careful about that. And the easy way to check it is exactly what I just showed you. Just try to lift up on the frame. If it's threading into the actual plastic post, it'll be good and you won't be able to lift it up. If it's not, you'll be able to easily pick that side of the frame up. So let's try that again and see. Now it's welded down, so we're good this time. right. Get this guy going. I'm using slightly longer screws. I don't know where I got these from. The reason I'm using slightly longer screws is that the grommets that are on this X12 are a little bit taller than normal grommets, just to make absolutely sure that the USB port is not going to hit the battery in this thing. This screw was just trying to do the same thing. The other way that you can tell is that it won't tighten. But you don't really want to tighten these much because you're screwing into plastic. And so always make sure you're not cranking these things. Never crank these things down, I should say. As soon as you start to feel a little bit of resistance, that's where you want to stop. And so also, like, get a really thin screwdriver to do this with and just use your fingertips. If you're just using like 2 fingers like this, you'll really feel it start to tighten up. And you won't over tighten it at the same time. It's super easy to strip out these plastic posts. There we go. That should be good enough. This is one of my custom ORT antennas that are 4.6 centimeters. They have a little bit of extra long piece of shrink wrap here so that you can tuck it into the frame like this. And it gives the antenna a little bit more resistance versus when it pulls all the way out and it's floppy because it's just the wire. You still do want to put a little bit of E6000 on the plug, on the UFL plug, but this is just a slick little thing. I'm actually thinking about asking them to add another 2 millimeters of shrink wrap to the next run of these that I do, but we'll see. All right, let's get this testing rolling. So I'm going to set this to 4 volts, this being the bench power supply. I'm going to hit the button. That's now sending that 4 volts through to the BT 2.0. I'm going to fire up Betaflight, and we're going to plug the quad into USB because we need to get into the motors tab. First thing I'm going to do is plug these motors in because they'll have a hard time spinning without any electricity. Tonight's live stream is 100% electronic, my friends. I always forget to say that. It's like my favorite. I don't remember where that's from, but somewhere there was somewhere someone said about something electronic that it was 100% electronic, and I just thought that was the most hysterical thing ever. All right, come on now. Get in there. Get in there, JST. Plug, you bastard. There we go. All right, 2 motors are good. Let me just make sure. Yeah. And that wire that I put on there was plenty long. Motor number 3. Get in there. Yes, first try. Hell yeah. And then the 4th motor. And so what we're going to do with the prop on testing is we're just going to look at what RPM it is able to get to with the propeller on. And that's going to tell us a lot. The more powerful a motor, the harder it's going to be able to push a prop, and the higher of an RPM it's going to be able to push the prop to. What throws a wrench into that is when you test motors with different KV. The higher KV will spin higher, but that's a good thing. You know, what we're getting to see there is that the higher KV is going to make more power. That is totally normal. Look at this toothpick. I'm going to be flying this around. I flew it today, but it was a little too dark. We're going to be flying this on... well, we're not going to fly it on Friday's live stream, but we're going to look at some flight footage from it on Friday's live stream. Okay, cool. All 4 motors are on here. We're going to plug it in. Let's get Betaflight rolling here. And... let me write down on the sheet. Let me update the sheet with what these motors are. So I'm going to go to the bottom of the sheet with the big motors. And so we're going to go sub 250, 1002, 20 Oh, I already tested this one. Or did I? Hold on. Let me see. Sub 250. Sub 250. 21,000 kV. What the hell? Well, we'll see. I have a feeling I just typed in the wrong number. We'll repeat the test and we'll see if it turns out to be 36,000. Wait, I've tested these already. Son of a bitch. Flywoo 1002. No, I haven't. This is 19,800. Flywoo 1002. 19.8K. Okay. And then what do we have? Happy model? No. Then we got the sub 250. 21. Okay. So Flywoo, I'm going to actually reverse these. Yes, I know that you guys can't see this. It's going to be okay. I promise. Pace. Okay. So we're going to test the Flywoo first, then the... Is this the GEPRC? Yeah, GEPRC 25,000. Oh, shit. What's happening here? There we go. GEPRC... What the fuck? GEPRC 1002 25K. Okay, and then the sub 250, and last but not least is the notchy motor, which is the happy model 1002 20,000. Happy model 1002 20K. Is that what I said? 20K, right? Yep. Okay. All right. Good to go here. And so we just need the RPM at 50% throttle. So let's come over here. Betaflight, connect, motors tab, and I'm going to plug in the BT 2.0 connector. All right. And so this guy can just sit here, and we're going to do everything right in here. And so we're going to go like this. And now motor 1, we're going to hit page up 5 times, and we're going to take a look at what this RPM is. Ready? Page up goes 10% up. 10, 20, 30, 40, 50. And so that's given me 38,700. 38,700. So, balls. 38,700 was the Flywoo motor. 38,700. And so now we're going to do the GEPRC 1002. 25,000. Well, let me just make sure. Let me make absolutely sure that the right motor is spinning. Just real quick. Motor 1, that's correct. Motor 2, that's correct. Okay, perfect. So we're going to do motor number 2 next. And I'm just going to blast through the rest of these now that you understand how this test works. Ready? Motor 2. Page up. 2, 3, 4, 5. Wow, that's big KV. 50,500. Wow, 50,500. It might actually be 25K. Fucking A. 50,500. Damn, dude. Okay. We're going to compare that in a minute or two here, but let's keep going. Motor number 3, which is the sub 250 1002 21,000 kV. 1, 2, 3, 4, 5. 37,000. All right, so we got 37,000, and I'm just going to do the happy model. 37,000, and then the happy model is 38.5. 38.5, 37, and 38.5. 37 and 38,500. Okay. So that is kind of interesting. Let's pull the power from this thing, let it cool off a little bit, and let's talk about it. So, as a comparison point, the RC Power 1002 22,000 kV motor turned 37,500 RPM doing that exact same test. Oh wow. Okay, that's really low. The sub 250 1002 21,000 kV cranked 37,000. So that actually looks about right. But then check this out. The Flywoo 19,800 kV turned 38,700 kV. So even though it's stamped 19,800 kV, it turned an extra 1,200 RPM versus the RC Power 1002 22,000 kV. It's stamped 22,000 kV. Perfect example of what I mean. All these manufacturers are testing their KVs in a different way. So that's really interesting. What this test here doesn't tell us is how much grunt any of these motors have. And so this Flywoo motor could spin up to 1,000,000 RPM, but then when we put a propeller on it, if the magnets are really weak, it won't do shit with a propeller on there. But still, this is still figuring out what the actual KV of the motor is really important. Happy Model 1002 20,000 kV just turned 38,500 kV, super similar to the Flywoo 19,800 kV. So the Flywoo and the Happy Model are both turning higher KVs than the RC Power 22,000. That's super interesting. And now look at this though. The GEPRC 25,000 kV cranked 50,500 RPM. So what I'm going to do is I'm going to look on my chart at another motor that turned 50,000 RPM to see what the KV is of that motor. And so, okay, so I tested a VCI 0703 that is marked 23,500 kV. That motor turned 51,000 RPM, very similar. So that VCI motor is actually doing better. Let me see if I can find another motor that's right around 50,000 kV. What I'm curious of is the GEPRC 25,000 kV actually 25,000 kV? So I need to find another motor that's pulling roughly that same number. Let me do this also. I'm going to copy these and I'm going to drop them into the other tab in this sheet. And so I should be able to do that. Yeah, there we go. Kevin Sumner put a formula into this sheet. Oh, I know why it's not working. It's because I need to hit 4 and 4 and 4. Yeah. Here we go. Okay. All right. So awesome. That formula is now working. 4, 4, 4, 4. So with the formula that Kevin did with math, the Flywoo 19,800 kV is actually 19,350 kV. The GEPRC 25,000 kV is actually 25,250. That's awesome. The sub 250 21,000 kV is actually only 18,500 kV. And then the Happy Model 20,000 kV is actually turning 19,250 kV. So you can totally see some guys are right on the money, some are above, some are a little bit below. Actually, these are all a little bit below. No, actually, the GEPRC is above, so that's awesome. Here's really what I want to compare. I want to compare the GEPRC to the Betaflight 1102 22,000 kV. So let me do that real quick here. All right, where the hell is it? Here it is. Betaflight 1102 22,000 kV only turned 42,000 RPM. versus this GEPRC's 50,000 RPM. So I'm just looking at some of the other 1002s. Oh man, this GEPRC, even though it's really annoying that this GEPRC motor comes with bare wires, it is a significantly higher kV than any other 1002s or 1102s. That's really nice. That's really, really, really nice. I also tested a Happy Model 27,000 kV motor, and it turned 52,000 RPM in this test. 27,000 kV, 52. This 25,000 kV GEPRC motor did 37. And so, wow, this GEPRC motor actually looks really good. I only bought the one because I just assumed that it would be under KV'd like every other motor, but it's looking not. It's looking like it's pretty good actually. Stream is still nice and healthy. I got no dropped frames. So up next, let's fly the damn thing. Is that battery done charging? It is indeed. Let's see what happens when you have 4 completely different KV motors on a crod. How did this prop get so banged up? What on earth? And I've got the magical microphone hooked up, so you'll get to hear the damn thing. Although, you know what's interesting is that you shouldn't be able to hear anything weird. This is different than mullet-propping. When we did the mullet prop thing, bi-blades in the front, tri-blades in the back, the PID loop was adjusting the RPM of the front motors to the back motors because there were totally different propellers on front and rear. So the PID loop was having to limit the RPM of the motors that had the tri-blades on it. In this scenario, I'm putting the same props on all 4 motors, and so the PID loop is going to even the RPM out on all 4 of these motors. If we did a black box log, and I went full throttle, unfortunately the X12 doesn't have black box, but if it did, and I went full throttle, we might be able to see one motor being driven by the flight controller harder than the rest, or one motor getting... Well, so what would happen is the GEPRC motor would be drastically underdriven because it's a higher KV, right? And so that's basically what's going to happen here. We're not going to get to see it because no black box in Happy Model Land. But yeah, that's essentially what it's probably going to be commanding like 100% of the lowest KV motor quite a bit, which is the sub 250. So like motor 3, the flight controller is probably going to be pushing 100% onto that motor, and then it's going to have to limit the rest of them down. That's just going to magically happen though. Like I don't have to tell it to do that. The PID loop is going to run at 4,000 cycles a second because I have the PID loop frequency set to 4K. That's what 4K means, 4,000. And so yeah, this should just fly. But let's find out. There has to be a certain point. Oh my God, Stickflick FPV with a $50 super chat. He says, just because, keep up the good work, brother. Thank you so much for the support, Stickflick. It's support like that that literally allows me to do this. So much appreciated. Thank you for being a part of this research. I'm probably going to spend some of that $50 on 3 more of these GEPRC motors because we've been waiting for a high KV 1002 or 1102 for a long time. And it could be, and this is a 1S 75mm rig. And so I'm super curious if the GEPRC 1002 25,000 kV motors can come anywhere near the Treetopper setup. 802s on a 75mm rig like this are being pushed really hard, and they're kind of getting close to the limit of their performance. I gotta get these motors spinning the correct direction. I almost forgot. All right, so it's almost guaranteed that at least one of these motors is going to be spinning the wrong direction. So, and it looks like I need to unplug and replug the video receiver module. So we're going to go to motor direction. I understand the risks. The props are definitely off. All right, motor 1 is correct. Motor 3 rather is incorrect. Now it's correct. Cool. Motor 2 is correct. Motor 4 is incorrect. But now it is correct. Okay, cool. And so let's come in here, pull the master up a little bit and just recheck. Props in, props in, props in, props in. Let's listen to each one of these motors with a prop on. This is the flywheel. This is the GEPRC. This is the sub 250. This is the happy model. The happy model is a much more notchy motor, and sometimes that means a tighter air gap or stronger magnets. And so what's interesting is that the happy model motor might actually make the most power. Here's the thing though. The only motor on here that has enough kV to make any kind of power on these bi-blades is the GEPRC. So it really sort of doesn't matter. The other 3 motors don't really matter. I bought the other 3 motors to test them on 2S, but then I realized that they were a little bit too high of a kV for 2S. And so I'm probably not going to do anything with these 20,000 kV motors, especially because they tested at lower kV than what I really wanted. So yeah, probably not going to do anything with them, but hey, is what it is. That's fine. Here we go. 4 different motors, same propellers front to back, ranging from 19,800 kV to 25,000 kV. So the hover point is really high. Why is the hover point so high? Holy shit. Look at this hover point. 50%. Good lord. So the hover point is high because these are low kV motors. So basically what's happening right now is the lowest kV motor, all of the other motors are being limited down to the lowest kV motor. So basically the flywheel, all 4 of these motors are becoming the flywheel motor. And 20,000 kV is low. Wow, it flies like shit. It just doesn't have any RPM. But as you can see, it absolutely flies. Oh boy. It does fly with no drama at all. And if I put 4 of the flywheel motors on here, it would fly exactly the same as this. So like what I'm doing here is I'm trying to like find if one of the motors will make more power. So like the right front motor has the most power. So like if the PID loop weren't doing its job, when I did that, it would roll faster than when I did this. But the PID loop is just limiting everything. There you go, man. Feel free to run whatever the hell motors you want. Mix them, match them. But, again, the lowest power motor is going to be the one... Oh, I didn't have the cool microphone running. Hold on. I forgot to oh, both mics are on. Okay, so there might have been a little bit of a delay. Sorry about that. Here you go. Here's just the just this mic here. Ooh! I hit the mic stand. Whoever's wearing earphones is now deceased. What? Where is it? Teddy. Ooh. Spaghetti Man, what are you doing? Oh. There he is. Look at him. Oh! Well, there you go. Totally flyable. It's just, you know, again, the lowest power motor is, all of the other motors are getting drugged down to the lowest power motor. Does that make sense to you guys, right? Like, the PID loop is going to ask for an amount of power, and it's going to max out. So everything I do, everything I do when I slam the sticks, when I go full throttle, the PID loop is trying to hit set point as quickly as possible. So it's going to push as hard as it can. There's going to be one motor that when the PID loop pushes all the way up to 100%, it's given everything that it can give. And then the other three motors, the PID loop is going to push up to like 90%, let's say. And then that one motor is going to hit 100%, and the PID loop is not going to push beyond 90%. And so, yeah, wow, I can't believe how bad this flies with, although it makes sense. 20,000 kV is really low kV. Damn. But absolutely flies, totally fine. Yeah, check this out. This'll, yeah, listen to the difference in, so this is one other way that you can test 4 different motors to see which one makes the most power. You flip into turtle mode and you just listen. You fire each motor up individually with props on to drag the RPM down, and you just listen. Ready? Flywoo. GEPRC. Big difference, right? Sub 250. Happy model. So here's the 3 motors that are like basically 20,000 kV in a row. Ready? 1, 2, 3. All sound exactly the same, right? And now here's 20,000 and then 25,000. Big difference, right? So that's another way that you can pretty easily tell. Here's the thing, though. I did 3 of these motors in a row that sounded absolutely identical. The actual RPM that I was seeing with these 3 motors was 38,700, 37,000, and 38,500. So there's a maximum difference of 1,700 RPM between 2 of these 3 motors, and I couldn't hear a pitch difference at all between them. But then we fire up that GEPRC motor, which is 50,500, and we could absolutely hear a difference. So using Betaflight, like I showed you, and the motor tabs and that RPM telemetry coming back is much more accurate. That's what allowed me to see 38,700, 37,000, 38,500, right? That's way more accurate, and there's no reason not to do it. It's super simple. You have to have a bench power supply, though. You can't do that testing with a LiPo, because every single time you ramp one of the motors up, it's going to discharge this down and the voltage is going to change a little bit. With the desk power supply, I set it to 4 volts, and it's 4 volts the whole damn time, right? So using a LiPo is unfortunately not really good enough to do that kind of testing and get some like repeatable results. Man, I'm really impressed by this GEPRC motor being 50,500 kV. That's a lot more kV than the Betaflight 1102 22,000 at 42,000. 42,000 versus 50,500. That's a massive difference. To put that in perspective, though, I tested Happy Model 802 33,000 kV. You know what I didn't test, though? I didn't test the Treetoppers. Let me test the Treetoppers real quick. It's a different X12, but it should be fine. Because without the propeller on, you're not stressing the FETs out. So yeah, let's try these Treetoppers. I bet you. So I built some Frankenstein Happy Model 802, 27,000, 30,000, and 33,000 kV motors. And those motors turned 52,000 RPM for the 27,000, 60,000 for the 30,000, and then 60,000 again for the 33,000. These Treetoppers make way more power than all of those 802s that I'd kind of Frankenstein together. When I say Frankenstein, what I mean is I took tiny whoop motors that had 1mm motor shaft bells. I took those bells off, I kept the stator, and I put 1.5mm motor shaft bells onto those stators that were those numbers. The Treetoppers are a 0802 33,000 kV motor with a bell on them that has a 1.5mm motor shaft, so I don't have to do this weird bullshit of swapping bells. And so, yeah, this is an X12. I'm plugging it in real quick here. We got 4 volts going to it. Should get a couple of beeps. Oh, actually, no, it's not going to beep. But that's okay. We're going to fire up Betaflight, connect, and it's motor 1 that has no prop on it. So we're going to go to motors. We're going to zoom in. We understand the risks. And then we're going to page up 5 times, and we're going to watch this RPM number skyrocket. It should go above 60,000. Let's find out. Oh, wow, it's not. That's really surprising. 56,100. 56,100. Wow, I didn't expect that. 56,100. Hold on, let me add that to the sheet. Treetoppers. What did I just say? 56,100? Actually, I think it was 200. It was like 56,170 or something. Wow, that's interesting. Okay. So, oh man, with the math, that means it's only actually 28,100 kV. So that would explain why the Treetoppers are so efficient. The fact that they make noticeably more power means that either the magnets are stronger, the air gap is tighter, the windings are better optimized. That right there is super, super, super interesting, actually. Hold on. Let me throw a Gemfan 1610 propeller at this thing. I want to crank this up. Oh, well, no. Hold on. I didn't do any of the thrust testing yet. Let's do one quick hit of thrust testing with this, and then we'll thrust test the other 3. When I say thrust testing, what I mean is I'm going to put a propeller on it. I need a Gemfan 1610. Here we go. And you got to make sure that you put the correct directionality on. So I need left side high. Here's one. Nope, that's the right side high. Where was it? Here's the left side high. Okay. Putting a propeller on. That prop's probably going to rip right off. So now I need to turn this down to 3.8 volts. Okay, so now I'm out. This is just the way that I did the previous testing. 3.8 volts, Treetoppers, and I did crank it up to 100%. So this is going to make some noise. 3.8. And, all right, doing the test the same way. We're going to come in here. This is going to be a little sketchy. I'm going to need to hold it in my hand, otherwise it'll fly away. Is it going to blow? What's it going to blow away? It's going to blow away these screws. Move these over a little bit. All right, let's see. Zoom you guys in. And we're doing the same thing. We're reading the RPM, but now it's a loaded stand. Ready? Here we go. 49,500. Give it a split second. Let's hit it again. I'm just going to call that 50,000. Because I was seeing 50,000. So let me put that in here. 50,000. And yeah, look at that. Okay. So, very interesting. 1610 prop. All right, let me get this thing to stop beeping. Ooh. Hold on. Let's compare that to an HQ ultralight. Oh, yeah. I got an HQ ultralight on motor 2. I don't think I've ever done this before. This is going to be cool. Actually, I have HQ ultralights on all 3 of the other motors. Let's get a little control test going here. Ready? These are all HQ ultralights. 49,500. 49,000. 52,000. Motor 2 is a little weak. I saw a 51,000 on motor 3. Motor 4 is very strong. Hit motor 1 again. Yeah, it's hitting right up there at 50,000. So, all right. I just threw a lot at you guys. So, with the propellers on and holding this thing in my hand, it becomes a loaded thrust stand. It has to take static air that's not moving it and accelerate it down into the propeller and then push it out the bottom. This is a thrust stand. This is what a thrust stand does. This does not represent what happens in the real world, because in the real world, as soon as you add more than hover throttle, it starts moving forward. And when it starts moving forward, it's moving into that static air. And the faster it moves forward, the faster that static air is coming into it. And so you got to be careful with thrust stand data, because it's not the actual situation. It is putting more stress on the motor than you get in real life. So sometimes, like, if you've got 2 motors and on the thrust stand, one of those motors isn't doing quite as well as the other motor, you may very well go fly them and they'll perform exactly the same, because when you start moving through the air, it becomes an unloaded situation where the incoming air has some momentum, some velocity. And so, like, especially like if you've got 2 motors that are different KVs, and the higher KV motor on the thrust stand isn't actually making any more thrust, but then you go fly it, the higher KV motor will probably perform better, because it becomes unloaded the second that it starts moving forward, and that's going to make that higher it's going to make the higher KV motor need to do less work. Make sense? One of the things that we just did is test how healthy are the FETs on each one of these channels. Motor 4 turned 52,000 RPM. These 2 turned, I think motor 3 turned 51,000 I saw, and then motors 1 and 2 turned 50,000. So that could mean that the FETs on channel 4 are the healthiest, or it could mean that motor 4 is wound a little bit better. Maybe the windings are a little bit neater. Maybe there's a little bit more winding on the outside of the stator pole. Maybe the air gap is a little bit tighter. Any number of things could make motor 4 perform a little bit better. I'm actually kind of bummed there's that much of a difference, 52 versus 50,000. That's kind of annoying. Also, we saw the lowest RPM on the GEMFAN 1610. So we're comparing a 1.6 by 1.0 propeller from GEMFAN to an HQ 1.6 by 1.2. The 1.6 by 1.0 should never turn a lower RPM than a 1.6 by 1.2, because it's technically a lower pitch, but we've got two different manufacturers making two different propellers, and if you look at the blade profile between the two, you can't tell me that this propeller right here doesn't look like it's going to make more thrust than this one, right? And again, one prop manufacturer may very well be calculating the pitch in a totally different method than another. What I think that we just learned is that the Gem, and this is what I've felt in the air, the GemFan 1610 is actually going to make a little bit more power than the HQ Ultralight. And that's what it's always felt like. Whenever I've paired this GemFan 1610 with a really beefy motor, it always feels like it makes a little bit more power than the HQ prop. The HQ prop is much lighter weight though. And so the HQ prop has better flight characteristics. It handles prop wash better. The problem is it's fragile. And then this GemFan 1610 is like goddamn indestructible. So that was actually a really cool little part of that test that I wasn't really expecting to do. So Treetoppers hit 50,000. So now we're going to compare the Treetoppers with the Frankenstein Happy Model motors that I made. Oh man, and that I was interesting. Really interesting and really weird. Why is this? So the Treetoppers did not hit as high of an RPM as the Frankenstein 802 33,000 kV motors, but I swear to God that the Treetoppers make more power because I back-to-back that. The Happy Model 802 30,000 and 33,000, no, I'm sorry, just the 33,000s, they turned 52,000 RPM. The Treetoppers only turned 50,000 RPM. But what's actually super interesting is that the Treetoppers unloaded, no prop on, only turned 56,200 RPM. The Frankenstein 33,000s did 60,000 RPM. So, and again, the Treetoppers are insanely efficient. And so you can see that efficiency right there. The Treetoppers are actually a lower KV, but they're turning almost the same amount of power. It's really weird that the Treetoppers didn't turn a higher RPM with the propeller on. They came close though, 50,000 versus 52. I have one of these. Okay, we're gonna test this real quick, real quick here. Where'd that quad go? I'm gonna put one of these 802 30,000s onto that build if I can find it. Where the hell did it go? Here it is. Yeah, I'm gonna pop one of these Treetoppers off, and I'm gonna take the one off that's on motor 2 because that was the weakest FET, and that's the one that we saw 50,000 on. I have to know real quick here. There's a lot of variables here. I've done this testing on maybe the same AIO every time, maybe not. This is a different AIO on this build here. And so what I'm doing right now is I'm trying to take a variable out of the equation here. Let me use a red. Let me use one that's going to turn the correct direction. Yep, there we go. Is anyone still following me, or am I so deep in the weeds that everyone has just tuned out? It's also probably pretty late. 12:12, yeah. It's pretty late. And I am going to put a prop on this. So we're going to test this. No prop and prop. Sorry to be completely ignoring chat, but this shit fascinates me. and I'm always dying to know, like, I fly this stuff, and sometimes I can tell for a fact that one is making more power than another. Sometimes we can look at the RPM data and be able to tell. Sometimes it's just obvious from flight feel. And then more often than not, I'll do some sort of testing, and it'll back that up. This is usually it backs it up. In this case, at the moment, it's not, and that's pretty unusual. And so let's take a look here. This is the 33,000 kV motor that, when I tested it previously, turned, with no prop on, it turned 60,000 kV. Let's see what it does. It's on motor 2 at 50% throttle. 1, 2, 3, 4, 5. Yeah, see, so this is this too many. Well, you know what's interesting? I went up to 60% and then back down to 50%, and it started turning a higher RPM. Hold up. When I did that, it turned that 60,000 RPM. But hold on. Where's that Treetopper? Oh, I didn't need to unplug that. I just need to pull the prop off. Hold on. I'm testing the Treetoppers at the moment. Okay, so I actually need to plug this all back in. Plug this back in, and then plug this back in. Okay, so the Treetopper has no prop on it now on motor 1. So here we go, and motors, and okay, Treetopper, which is supposedly 33,000 kV, is on motor number 1. Frankenstein 30,000 kV is on motor 2. So we're gonna go 1, 2, 3, 4, 5, and that's 56,000. But watch this: 60% down to 50% comes right back down to 56,000. 56,000. 56,000. 56,000. Okay. And then Frankenstein 30,000. 60,000. It's repeatedly doing 60,000. Let's throw props onto both of them and see what happens. High left. I need a high right. Right side high. Nope. Left side high. Come on. Give me a right side high. Is that you? Yep. There we go. Okay. Right side high. Left side high. We're going to go props in. I kind of just did this, but I do want to back this up. There's a chance that I need to retest these Frankenstein 802 33,000s and maybe even the 30,000s. I think I sold the 27,000, so I can't retest those. I may have even sold the 30,000s. I don't remember. All right, this propeller doesn't want to go on. Let me hit it with the 1.46 millimeter drill bit so I don't ruin the motor. 1, 2, 3 times down the drill bit. That should be better. Come on, God damn it. What the hell? Why won't this? There it goes. All right, here we go. Power is hooked up. I got to turn the voltage down to 3.8. All right, we're good. So we're going to test motors 1 and 2. Let me make sure that they're spinning in the right direction. Motor 1 is correct. Motor 2 is correct. Okay, cool. So we're going to go up to 100% on motor 1. Check that RPM. Here we go. Ready? 50,000, 49,500. It bursted up to 50. Now let's try this Frankenstein motor. 46,000. Now we're talking. Okay. That much more closely matches what I feel in the air. So two 0802 33,000 kV motors. We're going to do that one more time. 50,000, 46,700. You can even hear it. All right, so I need to fix the chart here. 46,000. What was it? 700? Hold on. Let's do it again. 46,700. Yeah, that way more closely matches with the way that they feel in the air. Okay, cool. So, yeah, that's I'm glad. It was, and it's not just me. Everybody that has flown the Treetoppers on 75 millimeter builds has been like, yo, yeah, these make more power and they're crazy efficient. So here's what just happened. We've confirmed that the Treetoppers are actually a lower KV. Then, if you take a Tiny Whoop Ipomoea, which is an 0802 33,000 kV motor as well, but it has a 1 millimeter motor shaft on it, you pull that bell off and you put a bell on, an iGal bell on that has a 1.5 millimeter motor shaft. When you do that, that motor turns 60,000 RPM at 50% throttle with 4 volts going into the AIO. Versus the Treetoppers, which are only turning 56,200 RPM. So the Treetoppers, even though they say that they're 33,000 kV, they're actually testing out at 28,100 kV. The Frankenstein 33,000 kV motors are testing out at 30,000 kV. This is okay. This happened to all of the Happy Model motors. All of the Happy Model motors, when I test them in this method, they actually are a lower kV than what's stamped on the bell. We then put propellers on those two motors to load them down and to not just test the RPM that they'll spin freely, but to actually test how much power the motors have. And when we did that, the just like the way they feel when you fly them, the Frankenstein 33,000s only did 46,700 RPM, and the Treetoppers did 50,000 RPM. And so the Treetoppers are a lower kV motor, but they have stronger magnets or a tighter air gap or a better flux ring, or maybe when I was doing the Frankenstein setup, maybe the iGal bell is not sitting perfectly level with that Ipomoea, whatever the hell, however you pronounce it, stator. So maybe the stators are skewed a little bit, and on the Treetopper motor where we're not mixing and matching, I don't think this is the case, to be totally honest with you, but you never know. Maybe the Treetoppers, the magnets are perfectly lined up with the stator, and the rest of them we were off a little bit. It could have to do with the thickness of the laminations in the stator. It could have to do with the thickness of the winding material. It could have to do with how neat the windings are. There are like a dozen different things in motor design that can affect how much power that motor makes. The RPM that the motor turns with no propeller on it is just a function of the windings. It's really like I believe it's just the length of the windings. And that number doesn't matter all that much because, as we saw here, this motor has quite a bit higher of a KV, but it makes significantly less actual power than these other three motors. Make sense? That's pretty cool. I need to retest some stuff now, though. I'm going to retest a couple of these things. I wonder why the numbers were so high last time I did this testing. That's a little weird. While I'm at it, I might as well test these other three, just for the sake of argument. And because I have them on this build, and I'm going to take them off of this build. And so let's plug in USB. We're still at 3.8 volts, so that's good. I did the props on testing at 3.8 volts to simulate battery sag. You pretty much never go full throttle and see any more than 3.8 volts. And so let's connect via Betaflight. And so we've got motor 1. Well, I'm going to fill the chart out here. So here we go. Motor 1 is the flywoo. I'm actually really interested to see what this GEPRC motor does. This is actually going to be really telling, because if this GEPRC motor gets anywhere near 50,000 RPM, then it could be an even better option than the Treetoppers. I don't think it will, but we're about to find out. Flywoo motor. 47,000, not bad. GEPRC. Whoa! 56,000. We might have a winner, my friends. 47.6. Hold on. 47.6 for the flywoo. I'm gonna retest. I'm not gonna keep zooming in. It's driving me insane. GEPRC. 56,000. Holy shit, dude. Okay, that's pretty gnarly. Sub 250. 47,100. And then happy model. This could crank. This is the really notchy motor. Nope. 47,600. Same as the other ones. And then Treetoppers were 50,000. Wow. Okay. So that's even more interesting. Let me make sure that all the propellers are spinning the right direction one more time real quick. Because when you spin these props backwards, they're a lot less efficient. Props in, props in, props in, and props in. Okay, that looks good. They feel like they're all making thrust. Yo, the GEPRC motors. Holy shit, dude. Hold on. Let me disconnect and get this battery unplugged so that this X12 doesn't melt. 3.8 volts. X12. Yep. I did this test exactly like I did the other one. So, that's insane. Oh, okay. This makes... Oh, this is great. This is great. Yeah. This is great. Okay, so this is really cool. The Treetoppers, even though they say that they're 33,000 kV, which compared to the GEPRC's 25,000 kV is a massive difference, right? 8,000 kV difference between the two. But when you actually test the kV on them, the Treetoppers come out at 56,000. The GEPRC comes out at 50,500. So there's much less of a gap there. You've got an 802 versus a 1002. 1002 is a lot more stator, right? That's what, like 20-something, 22% more stator volume. That's big. That's a big difference, right? And so the difference in kV is actually a lot smaller than it seems in the real world when we actually test it. But then we put a prop on, and now we really see the difference between stator volume, because the Treetoppers could only crank 50,000 RPM, and the GEPRC just hit 56,000 RPM. So the GEPRC is going to make significantly more power. What's going to be interesting, though, is it's a heavier motor. The Treetopper is an 802, super lightweight. The GEPRC is a big, chunky 1002. Also, the 1002 motor is putting more motor, more bell in the airflow. So it's the motor itself is going to block a little bit more airflow. What's nice about that is it's going to stay super cold. And so the 1002 is going to be a much more repeatable, a much more, not reliable, what's the word? I always forget this word. Repeatable works. Every time you hit the throttle, it's going to give you the exact same amount of power. The 802s, if you're hammering on the throttle, you jump off the throttle and you hammer it again, it might be overheated from you being full throttle, and you might get a little bit less power that second time you hit it. The long and short of it here is that the GEPRC 25,000 kV 1002 is the second most powerful. Wow, no, it is tied. Again, patrons, you guys have access to this spreadsheet. It's called CiottiFPV Tiny Whoop Data. Just go to Tech Talk, use the tag Tech Talk. I'm going to leave a link to this article in Patreon after the live stream. This GEPRC motor just matched the previous most powerful motor, which was the VCI 0802.8. So basically an 0803, big stator volume, 3 millimeter tall stator makes mad power, 27,000 kV. That turned 56,000 RPM, same thing that the GEPRC motor turned, but the VCI 0802.8 only has a 1 millimeter motor shaft, and it's a heavier motor than 1002. 803 is a much heavier, more stator volume motor than 1002. When you increase the stator from 2 millimeters tall to 3 millimeters tall, that is a 50% increase in the height of the stator, and the height of the stator is what does the majority of the work. The width of the stator doesn't do nearly as much work. And so these GEPRC motors make a lot of power. What that might mean is that they hammer the shit out of the battery, and the runtime might suck on these GEPRC motors. The Treetoppers are magic, as all Happy Bottle motors are, because they make really good power, and they have crazy runtime, like way more runtime than they should. And so my hunch is going to be that the GEPRC motors will not get anywhere near the runtime of the Treetoppers, but they should make significantly more power, like 50,000 versus 56,000. That's a lot. That's a big difference. So yeah, I need to buy 3 more of these GEPRC 1002 25,000s. And once I have them, they go on this rig, and then I'll put the Treetopper rig back together. These two are the exact same thing. Mobula 7 V4 frame, Gemfan 1610 propellers, Happy Model X12 AIO, Mobula 6 canopy, Runcam Nano 3 camera. Little bit of a bigger antenna on this one than this one, but who cares? This will be the one with the bigger motor, so it's kind of perfect that it's got the better antenna. And at that point, I can fly both of these back to back with the same batteries. We can look at the RPM that they turn under full throttle, unloaded, flying through the air. This is really what matters, right? And that'll be another data point between these two, because right now, the data that we have is in a loaded thrust stand where I am holding this. This is, oh God, so help me God. If the Treetoppers in an unloaded state flying through the air turn the same RPM as these GEPRC 1002 25,000s, then I'm a motherfucking genius. Because that is what I've been saying forever, that like not many of the smart people will really get behind, which is that we just did a loaded thrust test, and the difference between these two motors was 6,000 RPM. And go figure, the 0802 turned 6,000 less RPM than the 1002, the bigger motor. And I'll betcha that's because we were doing a loaded thrust stand result. When we get these up in the air, I'll betcha there's a much less than 6,000 RPM difference If not, hell, the Treetoppers might turn a higher RPM in the air because the Treetoppers are actually a higher KV. The GEPRC motor only turned 50,500 RPM unloaded with no prop on it. There's a difference between unloaded and no prop on it, right? No prop, 50,500 for the GEPRC, 56,200 for the Treetoppers. So this is really cool. I've had this situation happen before with 65 millimeter rigs where exactly like this, the slightly bigger stator volume, loaded, holding it will turn a lower RPM, but then in the air, it'll turn a higher. This is awesome. I'm really, really, really excited to see if these what these GEPRC motors will turn compared to the Treetoppers once they're hurtling through the air. Damn. Very cool. I hope I didn't lose everyone. If I did lose you, we are all the way in the weeds. This is not FPV 102. This is not even like FPV 103. We're like college level, fucking graduate level FPV 104 at this point. You'll have absorbed some of this, and just keep watching, and you'll keep learning, and this stuff will start to make sense. Those of you that have followed along, congratulations. You're just an intolerable FPV nerd like me. This is cool stuff. I didn't expect this. Hey, let's fly a couple 65 millimeter batteries. We're not going to fly 6. I'd planned on flying 6. I got the Hummingbird V4 back together, and none of the batteries that I've charged will work with it because it's NX69. God damn it, Jim. I didn't fix the other rig that I wanted to fix. God damn it. It's 12:30. We're not going to fly any batteries. It's fine. Shortened live stream because YouTube screwed me. I'm going to put these batteries onto storage. Sorry if you wanted to see me fly 6 batteries. I flew 1 battery, so you need to fly your 6 batteries. Get it done. It's probably really late where you're at. Try not to wake everybody up. Just fly chill. Fly 6 a day, my friends. You'll be a way better pilot before you know it. Thanks for tuning in. Thanks for bearing with me as I did science. For the record, this is kind of bordering on bro science. There's a lot of variables here. But as I do more and more of this testing, 99% of the time, the results match how it feels in the air, and they match what they should. And so yeah, even though this is kind of bro sciencey, it's been incredibly accurate. Lots more stuff. CiottiFPV.com to support me. It's the only way that I can keep doing this. The colored ORT micro V antennas are up on the Etsy store. They're under the regular antennas, the regular ORT antennas. I have added a ton of shit to the Etsy store, so go check it out. Lots of 3D printed stuff, some propellers. There's even a full build up there. There's a full Walksnail 1S 75mm build up there. And I think when I'm done testing this toothpick, this is actually going to go up there for sale as well. But Friday's live stream, I think, is going to be about this toothpick because I want to get it dialed in, and I want to just kind of fart around with it a little bit. And so, yeah, lots of stuff on the Etsy store. Go support me by buying some stuff. Buy stuff that you don't even need. You like that? I like that. That's a new one for me. In the chat, Seth, I got your email. I haven't had a chance to look at it yet, but yeah, you're good for the giveaway. Denzel says, in before CiottiFPV needs stitches. FizzPV says, we need the equivalent test for motors as a 0 to 60 test. How fast can it spin the blades to max? That would be cool. Rosser would be able to test that. His setup will do that. A feel says, what do you think of the newbie drone Savage B1S long range? And should I enable RPM filtering on a tiny whoop micro? Yes, you should always use RPM filter on everything. And I'm not a long range guy, so the 1S long range thing. I don't really understand why you would do 1S long range. Like, what are you going to go 500 feet away instead of 400 feet? Like, 1S is not going to go very fast. So you're never really going to be able to go very far because you're stuck going like 20 miles an hour. So I don't really understand doing long range stuff with like smaller than 5-inch props and less voltage than 6S so that you can actually go fast and cover a long range. But that's just me. Uke says, GEPRC be spicy. Indeed. Frank Nicholas says, is it possible different FET/components on a motor channel affects RPM? Absolutely. Should each motor be tested on the same FET/motor channel? Absolutely. But I'm not going to unscrew and screw that many motors. I'm also not going to wear out the motor plugs on my X12s by unplugging and plugging that many times. Also, it would just take forever to do it that way. At the end of the day, I can feel the difference in between these things in the air. And in the air, when we get that RPM number in the post-flight stats, OSD, that's kind of all that matters. Like, what these things do with no prop on, what they do when I'm holding them, none of that shit matters. What matters is when you do a full build and you rip it through the air. And for the majority of the testing that I've done, not on this spreadsheet, that's how I've tested them. I've flown them. I've looked at that RPM. And so, when you guys ask me which motor is, to compare motors, that's what I'm basing that knowledge off of. Capital C is finding the stream fascinating. Love it. Denzel the Terrible says, do you prefer Jim James or Captain Holden? Captain Holden for sure. Sporny says, newbie drone did 12 kilometers, I think. That's pretty far, but I don't know. If I'm going to do something long range, I want to get good footage, which that is obviously not going to get. And I want to get out. Like, how long did it take him to do 12 kilometers? An hour? It's not my deal. It's long range is not my thing. Long range folks might absolutely love that. But yeah, for me, I want half decent footage, and that thing is probably analog. It's almost certainly analog. Thanks for hanging, friends. Bro science. All night, baby. GEPRC. Good job with these motors, as long as they don't completely annihilate the battery. I was hoping that the Happy Model motor, being really notchy, I was hoping that it would make some really good power. What I could do is put a quad blade propeller on here to really load this thing down. I might actually do this real quick. Not right now, but not while I'm streaming. But yeah, the sub 250... The sub 250 motor is not notchy at all. And did it do the worst? The sub 250 motor did the worst, 47,100. And so yeah, I'm gonna pop this off, and I've got a 4-blade 1.6-inch prop somewhere, and I'm gonna put that onto these two motors and see if the notchiness of the Happy Model will kind of like come alive. Let's just do it real quick. I can do it real fast. Hold on. We can do this quickly. This is notchiness versus no notchiness. So with these 1610 propellers, ouchie, these two motors made... The Happy Model made 47,600 RPM. The sub 250 made 47,100. So like really, really close. almost close enough that it makes no difference. I can't get this prop off. Well, I can't get the clone popper in between the propeller and the motor bell. And when that happens, I use the Propodial. And so the Propodial is going to slide in there. Bring this in here like this. And then don't twist. Hold the motor bell as tight as you can. Don't twist. And just pull. Propodial, yo. Every single Etsy order you guys do, I throw in a Propodial. For free! Where are those big dumb quad blades? I know where I have them. Yes. Here we go. Real quick. Put this back to 3.8 volts. I'm just dying to know. Where are those quad blades at? Where you at, quad blades? Is this them? Here's one. Okay. Props in. This smoke crotch gray one is going on the Happy Model motor. The Happy Model motor shaft is a little bit thicker. That's a high left. Now we need a high right. Thank you, Happy Model, for doing that. You guys know I love a good thick shaft. Red prop, high right. Ooh, baby, here we go. This will be a cool little side quest test. See what I did there? Shit, is that a 1mm? That's for 1mm. Oh shit, the prop I need is right there. High left, high right, yeah. Side quest test, here we go. Yeah, this, two unwallowed out propellers. On the Happy Model motor, it was way harder to put on than the sub 250 motor. So Happy Model is using slightly thicker motor shafts, maybe like 1.01 millimeters. All right, here we go. Motors 3 and 4. In theory, motor 4 will turn a little bit higher kV here. Let's find out. I'm just going to read the numbers out to you guys instead of zooming. Motor 3, sub 250. 40,000, Happy Model. Nope, 40. I mean, it hit 41,000, but it didn't hit like way higher. Retest it real quick. 40,300. 40,800. Yep, nope. Nope. Motor notchiness made no difference in power between the two. What is interesting is that quad blade only turned 40,000 RPM. With the 1610 bi-blades, those motors were turning 47,000 RPM. So there's a 7,000 RPM difference in these motors between 1610 bi-blades and 1609 quad blades. Interesting stuff. Thanks for hanging, friends. Be good. I'll see you guys on Friday. I think we've reached the end of the Castle Crash flight footage. Have we? Yep, we have. Castle Crash flight footage is done. Well, what the hell am I going to play now? We'll go back to the beginning. Here's DJI flight footage. I'm all out of ideas. Love you, bye. I'll see you guys Friday. Bye.